Welcome to the STEM Sessions podcast. I am Jarl Cody, your host and narrator. Several weeks ago, an excerpt from Wild Thing, a novel, depicting a humorous comparison between the metric and imperial measurement systems, was posted to the mechanical engineering subreddit. Paraphrasing the excerpt, it read, "In the metric system, 1 milliliter of water is 1 cubic centimeter in size, weighs 1 gram, and 1 calorie of energy increases its temperature by 1 degree centigrade. Whereas in the American system, the answer to how much energy does it take to boil a room temperature gallon of water is go F yourself, because you can't directly relate any of those quantities." The comments that followed were mostly in good fun. One correctly pointed out that the American system is not the imperial system, and another said if you change water to any other fluid in metric, the answer is also go F yourself. As these online debates go, this one was atypical. It was entertaining and neither side pushed too hard. But the typical debate surrounding metric versus American measurement systems always turns so dogmatic, which I find silly and pointless. And here's why. This is the STEM Sessions Podcast, Episode 2, Cults of Measurement. One of my pet peeves in STEM is the debate over which measurement system is better. The International System of Units, or SI, colloquially called the metric system, or the United States Customary System of Measurement. And actually, debate is too polite of a word. Debate implies the two sides present rational cases and may learn from each other. But this? It's almost a holy war. We have the SI cult espousing its perceived superiority, while the US customary system cult defends its position with yeah but counterpoints. Neither sect is more right, and neither is more wronged than the other. Before we dive in, I want to make a quick note about the terminology. Many people refer to the measurement system used in the United States as the imperial system of measurement. That's incorrect, but it's an understandable misconception. Being a British colony, the soon-to-be United States used the imperial system. However, as the decades passed, the units in the United States diverged from their counterparts in the imperial system. For example, a pint in the US is approximately 0.8 imperial pints. So while the unit names are the same, the quantities are not. I also want to make two disclaimers. One, during college, I had to memorize tables and tables of unit conversions in my chemical engineering class, which more than likely jaded me to this entire subject. And two, and probably more importantly, I'm an engineer in the US aerospace and defense industry, and as such, I primarily use the US customary measurement system and am thus biased towards it. That said, let's tackle why the US customary system is just as valid as the international system of units. Reasoning for the latter superiority boils down to 2 points. One, everyone should use the same system of measurements. And two, math and unit conversion within the SI are far easier than math and unit conversion within the US customary system. Yet, in my opinion, both points are completely trivial because neither has anything to do with the science or engineering being performed. First, the fact that everyone else does it is not a valid justification for change, nor is it even true that everyone else does it. Yes, people like to mock the United States as being one of only 3 countries that does not use the metric system, the other 2 being Myanmar and Liberia. But when you actually look into the details, it's not that clear-cut. Take the United Kingdom, for example. Its government officially adopted the metric system in 1965. Most industries, commerce sectors, and government agencies use metric in the UK. Yet the imperial system is still officially used for distances, miles, vehicle speeds, miles per hour, liquid volume, or pints, fuel economy, miles per gallon, body weight, stones, and others. In fact, according to a BBC article from 2011, a survey revealed, quote, 70% of customers found metric labeling confusing and wanted products labeled in imperial instead, unquote. So the UK officially adopted the metric system, but it still uses the imperial system in certain areas. And you know what? That sounds a lot like the United States. Allow me to explain. The US was one of the countries that signed the original Treaty of the Meter in 1875. It has been expressly legal to use the metric system within the United States since 1866, and in 1988, it was named the preferred system of weights and measures for commerce and trade in the United States. Visit the National Institute of Standards and Technology, which is part of the U.S. Department of Commerce, and you'll see the country's full history with the metric system, including Presidential Executive Order 12770, dated July 1991, which outlines, in great detail, the roles and responsibilities for implementing the metric system as the preferred system of measurement. However, while many foreign governments mandated that only SI be used, Executive Order 12770 confirms use of the metric system to be optional in the United States, stating, quote, "Metric usage shall not be required to the extent that such use is impractical or is likely to cause significant inefficiencies or loss of markets in the United States firms," unquote. Yes, the US uses gallons for our gasoline, miles for our road signs, Fahrenheit for our weather, and acres for our properties, but we use a lot of metric as well. Our food labels are required to list both systems. Healthcare and automotive industries are nearly all metric. Wine and liquor are fully metric. Many domestic manufacturers use the metric system in internal processes regardless of what appears on the final product's label. Even US currency is produced to metric standards. We simply do not make it mandatory across the board. And why isn't it mandatory? Well, because in my opinion, it is advantageous to work within the system that makes the most sense to the given application. This is also why I believe metric's ease of converting and scaling is an unconvincing argument for its use. In a given industry, you'll typically have a common range of dimensions or values for your products. I design hardware in inches. Most parts are in the range of a less than an inch to a handful of inches. Rarely do we design single pieces larger than tens of inches. In the latter case, we don't use feet just because the part is larger than 12 inches. We would say 33.5 inches, not 2.79 feet. When it's less than an inch, we use 0.25 inches, not a unit smaller than an inch. And even if we verbally say 25 mils, where a mil is 1/1000th of an inch, it's still written as 0.25 inches. Similarly, if I'm updating a weight model, I don't switch between pounds and ounces depending on the mass of the part. I stick with pounds and use decimals. This is also true for the metric drawings I encounter. Typically, these are commercial off-the-shelf drawings for electrical components with an international market. For these drawings, millimeters are typically the metric unit of choice, though they often provide inches as well. Do you know what happens when a dimension is larger than 10 millimeters? The drawing continues using millimeters. It doesn't suddenly convert those dimensions to 1 centimeter. You don't use multiple units of length on a drawing. If you start with inches, you use inches. If you start with millimeters, you use millimeters. So the alleged ease of conversion in the metric system isn't even a benefit to metric drawings. Now, some of you will point out that confusion must surely arise when I need to incorporate a metric-based part into a US customary-based assembly. And while I admit there have been stories of mistakes, I have not personally seen one. In fact, I'd say the root cause of those errors is not checking your work in the first place, and that is the mark of poor engineering, not of a poor measurement system. Ultimately, my point is this. One system of units is not inherently better than the other. Just like you wouldn't use inches when you're dealing with miles, you wouldn't use centimeters when you're dealing with kilometers. If your processes and machinery are set up for the US customary system, why invest the time converting to metric when it brings no value? If your transportation system is based on miles, and that's what everyone understands, why change to kilometers when it will just confuse everyone? The measurement system does not make the science or engineering better. Those concepts remain universal. I could develop the measurement system of les stem sessions with the Toki for my unit length, the Zap for my unit of mass, and so on. I could set the values and relationships such that all equations work properly, but that doesn't mean the system should be adopted. Machinery would need retooling and recalibration, documentation rewritten, people retrained, but it would still be a valid system of measurement. Units are simply a communication tool. Metric is not superior to the US customary system, nor to the British imperial system. Simply put, the better system for you in a given application is the one you're used to. Thank you for listening to this episode of the STEM Sessions podcast. I do my best to always provide accurate information, but unfortunately, I'm fallible like everyone else. so I encourage you to do your own research on the topic we discussed. Corrections and new information are always welcome. Show notes, contact information, and details of our other activities such as meetups can be found on our website, www.thestemsessions.com. If you receive value from this episode and wish to give some back, please visit thestemsessions.com/value for value for ways to support the podcast. And most importantly, please remember that STEM is not the exclusive property of experts, policymakers, or talking heads. Every presenter is susceptible to bias unconsciously or deliberately. So always verify what you read and what you're told. Do your own research, satisfy your curiosity, and keep learning.